I want to help make a skill tree for you. And this is not just interesting because you might be specifically looking for a skill tree, it also shows a bunch of interesting programming techniques and habits to get into. So as a quick overview before we get into the actual tutorial of setting up the basics, what we have here is a widget that has these nodes inside of it. Each one of these nodes can be unlocked or available. So you can see this one up here is unlocked, so everything it is connected to is available. This one is not unlocked, so the things below it are not available. Each node represents a skill, and this can literally be a skill in a gameplay ability system, whether it is Unreal's own gameplay ability system or whatever you programmed yourself. But it can go much further than that. It can be stat upgrades. It can even integrate with stuff like your inventory system. Maybe certain things in this skill tree give you items. Every skill will be entirely scriptable to do whatever you want it to do. It's going to be entirely asset-based. And in the same way, the unlocking methods are also going to be entirely asset-based. So we're going to have a bunch of different assets with different costs. Some of them might be entirely for free. Some of them might just check if you have a certain amount of experience. Some of them might check if you have a certain amount of experience and then take that as a cost. But again, these are entirely scriptable, so they can also check for items and whatever you might want to do. We can even make something where we unlock a skill in this branch of the skill tree, but in this branch of the skill tree we have an unlocker that checks whether or not we have that skill unlocked. It's super scriptable and super customizable. So whenever we unlock one of these, everything below it, as you can see, becomes available for us to unlock as well. Obviously, everything will be saved. These lines between all of the nodes that connect up will be automatically drawn as well, which I can show you in the actual widget viewer here. So if I take this widget and I duplicate it, for instance, give it a new node ID, we'll actually get around to setting this all up in today's video for the most part. Then I can go back into this one right here, and I can say in its next nodes we have, what is this one called? Lightning 3. So we say Lightning 3, and when we compile, it will draw a line between them automatically. All that while also having this widget that we can zoom in and out of based on our mouse position. And we can drag and pan along with it as well. So there's a lot of things to this. There's going to be a couple of different videos. In today's video, we're just going to be setting up the basic foundations of how a node of this type will work inside of our tree. So here in an entirely empty project, we're going to be reconstructing that. And as we go along video by video, I'm going to upload the project files for YouTube members and patrons to follow along with as well. So I guess the way that we're going to get started with all that is we'll make a new folder here for all of our skill tree related stuff. And the very first thing that we're going to be doing about this is just make a new interface thing for a widget blueprint. It'll be a user widget as per usual, and we'll call that WBP skill node. Everything that we're going to be doing today is going to be centered around building up the basic skill node. So let's set up the widget visuals for it before we do anything else. And we're going to be starting with a size box because I want these to just have a preset size. So we're going to set width, override, and height to, let's do like 50. And then we set this fill screen instead of being desired so that we can actually see the proper size of our little box here. Your mileage may vary. You might want this to be like 150 by 150, or maybe you don't even want them to be square. That's up to your own creative interpretation. I'm actually going to go back to 100 by 100. 50 by 50 is a little small. Inside that, we're going to be putting a button because obviously these are going to be buttons that we want to click on to actually trigger stuff with. It's entirely going to be a button, which then is going to have other stuff inside of it. There's going to be in the form of a vertical box. So we're going to be putting a stack of other widgets inside of this button, which once again, I start with a size box because that's just an easy way of setting up the size of a individual element. And we're going to be setting the size here for a image that's going to go inside of the size box. The image is going to be horizontal and vertical alignment fully stretched. And then the size box, we set a width and a height override in, which we set to a little smaller than the button itself. So the button is, I think we set it to 100 by 100, right? So let's set this to 80 by 80. Then we can set this to align however we want. I'm just going to align this to center, and then we can even set this to fill or auto. It doesn't really matter because we're using a size box that has these overrides inside of it. So these things, not the most important. Then one last thing is obviously we want to display the name of our node. So we put in the vertical box as well a little text block. Align that in the center, and then in here somewhere we have the justification as well. I'm going to center that too. And then the font size I'm going to set to something a little bit smaller. Let's do something like 12, seems pretty good. And we can set that to whatever font we want. I'm just going to keep with the default for now. Now we want to make sure that a couple of things that we set up here are going to be set as variables so that we can change them as we go along. So that's going to be the text, and we'll give that a name as well. We'll call it a name because it's going to be the name of the node. And then the image too, I'm going to make sure that that's set to variable, and we'll call that icon. And then lastly, the button itself is going to be a variable because we obviously need to be able to interact with that in our code too. Now you can tweak this a little bit. You probably want a little bit of padding between this size box and the name. So we can go into here, the size box itself. On the bottom, we can say, we want like 5 units of padding in there, and it just creates that padding. Probably want a little bit of padding on the top as well. And that way, there's just a little bit more room. It just looks a little bit more visually pleasing. With all that, it's finally time to go over into our graph mode and start doing some code stuff. The most important part being our pre-construct for now. In pre-construct, we're going to set our name and our icon, so we can just drag those in from our variables here. Those represent, obviously, the name and icon objects that we have here, the image and the text. And we need to set those based on some variables. So our name is going to be set text, and you can either use this pink one or this function one down here. Generally speaking, it's a good habit to get into to use functions and not set variables directly. So we're going to be using the function one. And we'll just make our int text here. We'll make that a variable, and we'll say that's the name. You can't just call it name because we already have a variable called name. So we'll call this node name instead. It's going to be a text. And we want to make that instance editable. So we expose it with this little eyeball icon. In the future, we're going to replace this with, instead of a variable, we're going to make a specific asset for each skill. And the asset itself is going to be housing the name instead. But for now, just setting everything up, let's just make some variables on here that we can then later replace. And with the icon, we do something very similar. What we do is we set its brush, which just means the way that it looks, its visuals. We set that from a texture because we're going to be giving in a texture for this. And once again, we just make that a promote to variable. We'll just call that the icon, skill icon, something like that, and expose that. Very much the same as before. We're going to be putting this inside of an asset in a moment anyway, but for demonstrational purposes, this is the way we're going to start with it. All right, now that we have this set up, we can actually start instancing this thing inside other widgets to make it do whatever we want. So this is going to be our skill node. Now we're going to make another user interface widget blueprint, and that's going to be our actual skill tree. And we'll call that WBP skill tree just because we're going to be good with naming things. This one will start by making a canvas panel. Generally speaking, we only use canvas panels for things that we directly add to the screen. This is going to be a slight exception down the line, and you'll see when we get to that how that exactly works. But for now, we're going to add this directly to the screen for just testing purposes, right? So what we do is we look up here our WBP skill node, and we can put those in. Now, you will note that it is kind of squashed and you can do weird stuff with it. If we enable size to content, it's going to actually size itself to that size box that we gave in before. So you'll see if I go back in here, I change this size box size to 200 by 200, compile that. Now, this one is also bigger because it's trying to always be the size that is set up to be in here. Which is going to be 100 by 100. I kind of like that size. If you don't have size to content on, it can be a bunch of different sizes, which might actually end up being somewhat of a problem down the line when we start drawing the lines between the nodes. So you want to have size to content being on. You also want the anchors to be aligned to the center in this case. And that goes for every single skill node that we make. So if we just copy and paste this one over a couple of times, The reason that we all align them to the center is because we want them to relatively to each other always remain in the same place. And aligning everything to the center point is going to make that happen for us. So now we can just go in here and I can say, well, the name and the icon for each one of these are exposed. So I can call this node 1, and you'll see it's going to be called node 1. Give it any random image and it displays that image. This can be node 2 with a different image and so on and so forth. So we've got our basic nodes set up. They don't do anything yet, but we'll work toward that in probably the next video. So for now, I just want to add this to the screen and keep this as a light introductory episode to the skill tree concept. So I will go in here, third-person blueprints, third-person character. I'm using the third-person template for this project. And in there, I will just add a debug key on the T for tree, because we're making a skill tree. And when we press this, I will just create a widget. The widget that we're going to be creating will be our skill tree. So we'll WBP skill tree. And we'll just directly add that to the viewport. And now we'll see, if I press the T key, I have my skill nodes on screen. So this is a very basic setup of how we can put these widgets inside of another widget to start creating our skill tree setup. Next time, let's take a look at actually changing these things out instead of being separate variables into having assets to give in and setting up a little bit of code for those assets to actually function as skill unlock assets. We have our skill node widgets set up for our skill tree system, but now let's actually make skills for these things to represent. Because right now I just added in a variable for a name and a skill icon as placeholders, more or less, so that we can have something to display. But in the end, what this is going to be replaced with, and that's what we're going to be making today, is individual skill assets that these are going to be sampled from, as well as being able to actually run some code when the skill is activated, when you unlock it in your skill tree. And the way that we're going to be doing that is, first and foremost, let's make a new folder here for classes. And I'm going to be making a new blueprint class. And we'll go to all classes and then look for data assets. We'll pick the primary data asset class. And for this, we can make a BP for blueprint, and we'll call this skill assets. If we then open this up, it opened up on my other monitor, because of course it did. This is a blueprint like any other, but instead of this being a blueprint that we use to put an object into the world, like an actor or even a component, this is going to be a blueprint that we use to make assets with. Any of the variables that we put in here, we'll be able to add it on a asset by asset basis, which means that we should put in our skill name, which we put in last time as a variable on the node itself, and then might as well make that instance editable as well. Same thing as we did here, skill icon as well, and we'll make that a texture 2D. So texture 2D, object reference, and then might as well add in something like a skill description as well, and make that a text, instance editable. And for this one, we can actually come over, as we have it selected, into the variable details advanced, so we can make it multi-line, which just makes it a little easier to write out bigger pieces of text. And then the really cool thing about this is we're going to be making a function. So we can add a function, and this will be unlock skill to player. Now, since this is an asset and it doesn't actually exist within the world, there's no real good way for this asset to get a reference to the player. You can't just get player character from here. So what we do instead is we want to give that in as an input for this function. So the player will be an input. We can just make that of type actor or pawn, most likely, so that other objects, when calling this function, can just give in the player instead. For now, all that I'm going to do here is add a print string. It takes in a world context object. It's not the most relevant thing. And what we're going to be doing is, this is a function that should never actually be called directly. This is only a function that we're setting up so that we can make child blueprints of this that have specific implementations for what it means to unlock this specific skill. So I have in my reference project here, I have written a string that's going to show that to us. What this is going to say is, if we ever run this, We say base class unlocker skill function call unlock skill to player override function in class. And then what we want to do is we want to get the class name or display name. And then we need to give in a class. The easiest way to do that is just to type this, and that gets you a reference to self. And from reference to self, we can just get the class from there. The reason that we do this is just for troubleshooting purposes. If we ever have this print string, which we should never get this print string, to be clear. This is just something to inform us that something is going wrong somewhere. This will also inform us which of our blueprint classes we actually need to look at that is accidentally calling this where it shouldn't. Now, one more thing, because this skill asset itself should never actually be used to make any assets of. This is just the base class that we're going to be making other blueprints of, and those are going to be used to make assets of. If that doesn't fully make sense to you right now, don't worry, we'll actually go through that process in a moment. But essentially, we don't want to be able to make assets of this class itself. So what we do is we come up here into class settings, we go into advanced, and we can say that this is a abstract class. That means that it exists and that our code can use it, but that we can't actually instantiate it in any way. So we can make child blueprints of it, and those child blueprints can be instantiated into actual assets, but this one cannot. And that's the basic setup for the skill asset itself. And just to show you the abstract thing real quick, if we go in here and I'll just make like skill assets, separate folder real quick. If we try to go into miscellaneous here and we make a data asset, try to look up skill, it's not going to be there because it is an abstract class. If I go back in here and I make it a non-abstract class and I try to go into miscellaneous data assets, and I look for skill now, you will see that it does show up. But we don't want to be able to do this. So that is why we mark it as being abstract. What we do, however, want to do is we want to go back into our classes, and we can just right-click on this one and create a child blueprint class. Or from this point on, anytime we create a blueprint class, what we can do is we can just look in all classes for skill assets, and we can click on that as its parent. It does the exact same thing. So let's say we make a skill asset that increases HP. Now, for that, our character is going to need to have a concept of what HP is. So let's go back into our third-person character blueprint real quick and give it a variable for HP. Give it a variable, just call that HP, and we're going to set that to being a float type, and let's set that to a default of 100. I'm going to add a tick event here, and just to show you this, let's do a text rendering component. Of course, this is not how you would display HP in your game, but I just want to show you this text is going to be displaying the amount of HP that we have. So the way that we do that is just in event tick. I'm just going to real quick like set text on every frame, and the text that we're going to be setting will be our HP value. You can set up a bunch of stuff here, whether or not it rounds or if it's always signed or not. What we're going to do is we just want no fractional digits or whatever. We just want the HP float itself. And just to show you, in-game, that now always will display 100 above my head. So great, our character now has HP, the most rudimentary HP system that you could possibly have, but that's all that we're going to be needing. Let's go into our BP increase HP. There we already have one function that we can now override, which is unlock skill to player. Now, this is going to by default call the parent version of this function. In this case, we don't want that because the parent version of this function doesn't do anything except print out a warning for us. So we don't want to run that. We instead want to implement our own code for what this skill unlock should mean. So what we do is we get our player and we have to cast that to our third-person character because we're going to be setting our HP value to our get HP value plus a certain amount. And this is where the thing with the different assets comes in. We get our HP and we add a variable to that. So let's add in promote to variable HP to add. Now we can make a bunch of different assets, an asset that adds 5 HP, an asset that adds 10 HP, an asset that adds 50 HP, and those different assets will have the different information on them. Obviously, just for adding HP, that is a little overkill, that's a little cumbersome, but the reason that we do it this way is because now we can set up things in a way where it's entirely scriptable on the asset basis, instead of relying on the skill nodes themselves in the UI. So we get our current HP, we add our HP to add, and that's pretty much everything that we need to do here. So now that we have all that set up, we can go into our skill assets and we can go make in miscellaneous a data assets. And you can see we have our BP increase HP already in there. So let's say HP add HP 5. Open that up. We get our HP to add, which is 5, and then the variables that we exposed in the parent version of this as well. So the skill name is add 5 HP. That can have an icon. Obviously, I don't really have any graphics for this right now. Do we happen to have like a heart? Nope. So we're just going to go with this green icon instead. And then we can write a description, which will be add 5 extra HP to your current max HP to become even stronger. Something along those lines. Just a little bit of flavor text. So we now have this asset. We can make a new asset by either just duplicating this asset or going again into miscellaneous, data assets, increase HP. Generally, once I've made one, I just find it easier to just Control D them and just make a new one. And then we can add HP 10. And this one, we just add 10 HP and so on and so forth. Of course, you could write the code for this slightly differently so that you don't have to make an asset for every single permutation of different amounts of HP that you want to take in. You could make a dynamically created data asset and just give in whatever value you want through code into that instead. But for now, I prefer to just stick to actually just making a bunch of different assets. Also, keeps things a lot more organized and just generally is probably fine enough. So now back into our skill tree node widget. Instead of having the variables that we had here before, which are the name and the icon, we're going to be removing both of those, and it's going to warn you that those are in use. We're going to be replacing those. And we'll make instead a variable for our skill unlock, or skill to unlock, or whatever you want to call this, skill to unlock. And that's going to be of type skill, BP skill assets object reference. Again, this does need to be exposed. And then we can see, if we pull this in, we can get any of the variables that we made on that skill asset as variables that we can get from this. So we can get the skill icon. That's going to go into our set brush from texture that we already had from the previous video. And we can also get the name, get skill name, and put that in there. And now, if we actually go into our skill tree, which I still have open right here, we can set our skill to unlock to add 5 HP. And you can see immediately it shows you the icon and the text. If I change this to add 10 HP, it properly reflects that immediately as well. Now, the only thing left to do is actually make this thing functional. So what we want to do is in our skill tree itself, for now, is we're going to be putting in on event constructs. I'll just get the player controller and I will set the input mode to UI only so that the camera doesn't freak out when we move the cursor. And the widget to focus doesn't really matter because we're not going to be working with that at the moment. And then we also from player controller want to set show mouse cursor to being true because otherwise we don't know what we're clicking on. Then, inside of the skill node itself, so we're back in this widget, we have this button right here. Our button, in my case, it's 54. It might be called something different for you. And we're going to go to the onClicked event. So we can add that as an event into our event graph. And this is just pretty much whenever we click this thing, we want to set this skill to unlock. You can right-click this to convert to a validated get, just to make sure that we're actually working with a valid skill asset. It is empty. You generally want to prevent accessing empty references to objects. And then we can just run the unlock skill to player function that we created. So here we have to give in the player, but that's easily done with get player character. because this thing actually has the context of being able to get the player character. Now, if you have a more complex game set up where your UI already has a reference to the player character as one of its variables, which very likely would be the case, you can just provide that in instead of using the get player character, but that ends up effectively being the same. So now, when we click on these buttons, we should start adding HP to our character. So let's do that. Let's make sure that we can see the amount of HP that our character has, nice and easy like this. Press the T key. You can see now I have my cursor again and the camera doesn't move around. When I press this, it adds 5 HP. When I press this, it'll add 10 HP and our skills just work. Now, you can still, you can spam these because it's just every time they're clicked, they will execute whatever is in the asset that they have. And that is something that we're going to be fixing, but we're going to be fixing that in the next video because it kind of ties into the way that we're going to be setting up the skill preview text that you saw in my initial video at the start. That is going to be the widget that's going to allow or disallow us to actually reacquire a certain skill. For now though, if you want the project files of any individual part of this series, you can find them down below for patrons and YouTube members. It helps support me doing these more long-term, more in-depth series, and it lets you mess around with the code that's being written in these videos. Fantastic. We have technically a working skill tree because we have skill nodes that do stuff to our character when we click on them, but we can spam them and we can't actually see any of the information about them, and they're just kind of generally a little bit weird in the way that they work. So let's build a better UI that previews whatever skill that we're going to unlock and then has a unlock button inside of that UI instead of directly just clicking on the thing and hoping that it is what we want to get. So to get started with that, let's go back into our skill tree folder here and add in a new user interface. And this is going to be our user widgets. WBP skill tree menu is what I'll call this. So this is going to be housing our skill tree, as well as a widget that will show us information about whatever skill that we're clicking on. So since we're going to be adding this directly to the screen, we add in a canvas panel first. And you might be thinking, I told you that you only really generally add canvas panels one at a time. And what we're going to be doing next is going to shock you because we're going to be adding our skill tree into this canvas panel. So right now what we have is a canvas panel within a canvas panel, which is generally something that you try to not do too much. The reason that we do it here is because we need the canvas panel in one sense for proper UI scaling on different aspect ratios, different resolutions. But for the skill tree itself, we still need it to be a canvas panel because we want to be able to freely move around these things within here while still maintaining their relative position to the center properly. So we actually need both of these to be canvas panels. Now, you can put this in however you want. Then we put in the anchors for it to be whatever size it is. And one important thing to note is that if we make this thing very tiny, you can see still outside of the bounds of our canvas panel, we can see the contents of whatever is inside it. And the bigger our skill tree is going to go, the more that's going to not be a good thing. So if we just, again, set this to being very thin, we can scroll down here, and at some point you're going to be seeing in rendering, quite near the bottom, we have a clipping option. We can set this to clipping to bounds, and now it will only show the actual contents within the bounds of our widget. And the best way to maybe show that off is to actually put in a image for now in our canvas panel, and that image, and then we set that to be aligned to the center as well. And we make sure that that is alignment 0.5, 0.5, position 0, 0. So it's actually aligned specifically to the center. And then we can set its size to being something like 15,000 by 15,000. So it's actually super huge. We also want this to be the first thing in the stack so that it is at the bottom. And then we can set the color and opacity to something slightly more pleasant, like this gray and then kind of see-through. But this thing is now absolutely huge, right? So if we go back into our skill tree menu, you can see that it still does get cropped to the bounds of whatever it looks like in here. Small little thing, but quite important to take into account. Now, we're going to be needing to make a new little widget here as well. And that widget is going to be a user interface thing, user widget, WBP, and we'll call this skill info. The skill info is going to be a overlay, not a canvas panel this time around. And inside of that overlay, we're going to do something quite similar to what we just did with the image. And we're going to be putting in an image for the background. This image, however, is just going to be stretching horizontally and vertically to its max. And then we just set it to like a see-through pleasant gray. You can make this any color you want. You can give this a texture. You can give this a material. Again, whatever you want visually. Doesn't matter. It's just to make it a little less boring. And alongside that, we're going to also put in a vertical box in the overlay. And then everything about the info is actually going to be contained within this vertical box instead. So this vertical box is going to be containing a size box because we're going to be housing a image inside that. And that image is going to be the icon for the ability as well. So this size box, we can set to whatever scale we want. I'm going to set this to a width and a height of, again, just 100 seems pretty good to me. And this one I'm going to align to the left side and then make sure that the vertical alignment is still set to fill vertically. We can also then give it a little bit of padding so that it's not snuck up against the corner like there. So let's give it 50 units of padding just so that it has a little bit of room on each side around it. Then I'm going to actually wrap this size box with a horizontal box. So we create a horizontal box above this size box. So what we have now is we have our vertical box. Inside that we have our horizontal box. And inside that we have our size box. Inside that we have our image. This horizontal box is also being used now to contain the name of this skill. So horizontal box contains both the size box with the image and then the text for the name. Let's also make sure that we give those variable names for now already. So we can call this icon and this one name. And we know that this is going to need to be a variable. So let's just immediately set that to being a variable. I like to vertically align this to the center so that it is, well, looking nice and centered. And then horizontal alignment, we can set that to left aligned. Doesn't really matter in this case. And then the justification can be left as well. The padding, I'm going to set left to 50 for this too. So that there's a little bit of distance between these. And that's pretty much all there is to the name. So we can now collapse this horizontal box again, because the only thing that we needed there is just to have the icon and the name next to each other. Everything else is going to be stacked vertically under each other from this point. So the next one is also going to be a text. This is going to be the text for the description. Make sure that it actually gets put into the vertical box, not into the horizontal box. I accidentally put the name outside now. Okay, yeah, there we go. It takes a bit. And then we set the padding to the left here to 50 as well, so that they're nicely aligned. And this is going to be the description, which obviously also needs to be variable. Now for this, I'm going to make a little bit more room in the UI real quick to show you what I'm going to do. This is now aligned 50 padding to the left, but it still has padding all the way to the right. So we want the right to also have 50 units of padding. And the reason for that is that if this is a very long text, we want it to wrap around before it reaches the very end of this widget here. And speaking of wrapping, we're going to look for wrap and we can say auto wrap text. If we just enable that, it's going to automatically just make a new line of text whenever we reach the end of however big this widget ends up being. This is the nice thing about a lot of these Unreal Engine widget components is they're fairly intelligent in the way that they work. If you have a super long widget on like a very wide monitor, it can contain a lot of text on one line. If you squish that widget down, because either it's a small part of a bigger screen or just because you're on a very narrow monitor, like a phone screen or whatever, it will still just intelligently wrap whenever it needs to the next line. Then also, I'm actually going to set this one instead of auto for its size to fill, which means that it's going to be filling the entire space that it has here. And the reason for that is because we're going to be adding one more text in here inside of the vertical box, and that'll be the cost, which once again I just set to have 50 units of padding on each side. And you can see because this text block now takes up everything that it can, it pushes this one all the way down to the bottom. And that is 1000% what I want. I want this one to be aligned all the way to the bottom, this one to have as much room as it can take, and then we have this one up here aligned to the top. Once again, the cost itself is going to be a variable text, obviously. And then as the very last thing that we're going to be adding is we'll add a button. Because all this is to, on the one hand, display information about our skill, but also confirm that we want to actually buy this skill or get this skill, whatever you want to call it. So once again, I'm just going to give this 50 units of padding to each side, and maybe actually have the bottom of our cost text not have any padding. Because what ends up happening if both of these have 50 units to each side, there's going to be 100 units in between these two, and that's just a little much for the way that I like these to look. So either this one needs to lose the padding to the top, this one to the bottom, potato, potato, ends up being the same thing. One more text to just put inside of the button. This one doesn't even need to be variable. All that this is going to say is this is just going to say unlock. And this is going to be our widget info and also unlocker widget. So time to put in some code. So let's go into our graph, and instead of directly programming inside of construct or pre-construct, because we're going to need to update this initially whenever we construct this thing, obviously, but also then later on when we click on any given other widget, what we're going to do is we're going to put this inside of its own custom event or a function, whatever you prefer. And we'll just call that update skill info. And this is going to be taking in the skill node that we have just clicked on. So it needs a input here, which we can do right there. And this will be just skill node. Let's call it that. And it's going to be of type WBP skill node, object reference. Now, very first things first is that's immediately going to become a variable. So skill node to display, just so that we can easily keep track of it. And we then, whenever we update this, we want to check, hey, are we updating this to a actual new skill node value, or did we get given in a empty value, which means that we're going to be displaying nothing right now, which is going to be the case most likely on initial startup of this widget. What we're going to do is we're going to check if that new value that we've just gotten in is valid or not. Because if it is not valid, effectively everything within this vertical box is going to need to be no longer visible. So we make the vertical box itself a variable, and then we just set its visibility. So set visibility. And we can either set this visibility to being hidden, which just means that it's invisible, or collapsed, which if you put this within other widgets itself, means that it's also going to be taking up no more physical space in the layout. In this case, hidden will do fine because there's nothing else going to be below or above this vertical box in my case. If that is the case for you and you want that to actually expand and contract based on this, you would use collapsed instead. However, if whatever we just gave in is valid, we want to also set the visibility, but now we're going to be setting it to visible. And of course, hook this up to the vertical box as well. Don't worry if this already is visible and we're setting it to visible again, nothing really happens, that's fine. And then from there, we effectively do the same thing that we did inside of our skill node itself, as you might remember. Here on pre-construct, what we did is we took the skill and we took the name and we used that to set the name, and we used the icon to set the icon, and so on and so forth. We're going to be doing the same thing here in the skill info. There's just going to be a couple of extra nodes to it. So we have our skill node to display, and that skill node to display has a get skill to unlock. It's the variable that we made on it. From there, we can get the skill name, we can get the skill icon, and we can get the description for the skill, which I mistyped, I see now. And from there, it's easily just, we get the icon, we get the description, and we also get the name, and we just set everything accordingly. So in the name, we set text very easily to our skill name. Once again, it is a better habit to use functions whenever they are available to set variables. Just, it doesn't matter in this case, but as a habit to get into, it's a good thing to do. Because sometimes a function might do more than just set the value, and usually you'd want to have it do whatever else it's also going to do. So we set brush from texture with the icon, and then the texture is going to be the skill icon. And then we set the text as well with the description. Now you might notice that we're not setting any cost text yet, and that is because we don't have a mechanism for costs yet. So we're going to be doing that in the next video, setting up the code for the costs, which will function very similarly to how we have the skills set up. We'll circle back to actually giving this cost thing its proper like text value once we actually have that stuff in place. So with all that, we have this update skill info. Now on construct, and maybe even pre-construct, depending on what you want in the designer. I'm just going to do this on normal construct. We just want to run this with an empty value. So on event construct, we update skill info and just give whatever we give in as empty. What that's going to do, as we said before, it's just going to make everything invisible until we actually give in a value. Now, how do we give in values to this? Because we don't really have any code set up for that yet. Do we? No, we don't. But it's fairly easy to do that. So what we're going to do is we go back into our skill node. So that's this widget over here. And all that we really need to do there is we need to add in a event dispatcher. And we'll call that on node selected. And we give that an input in the new parameters with it selected here. That should be a possibility. And we'll call that just node. That'll be of type WBP skill node. So all that this is going to do is whenever we click on this button, instead of directly just unlocking this skill, it will just call out this event dispatcher with a reference to self. That way, our other widgets can listen out for this thing and get given through the thing that was just clicked on. Obviously, that means that we are no longer unlocking the skill when we click on these buttons. So we need to just change that around to a custom event, and we'll just call that something like unlock skill. That way we can externally run this from a different widget, which is what we're going to be doing with the widget info viewer. But that still doesn't get us from an individual node all the way to our skill info, right? Because how do we bridge that gap? Well, first and foremost, if we go back to our skill tree menu, we now have our skill tree info that we can put into this widget as well. And we'll make the anchors, again, scale up properly and everything like that. And these two are now inside of the same widget. So we can start making information go from the skill tree to the skill info widget. So all we need to do is inside of the skill tree widget, we need to listen out for every single one of these buttons emitting their event dispatcher. And then when that happens, we need to just kind of forward that signal so that this thing can listen to just one signal instead of a billion different signals, which might end up being a bit of a headache. So what we do is inside of our skill tree, we also just make an event dispatcher, which we'll call on new node selected. And this pretty much does the exact same thing. It just forwards the signal from the individual nodes. So we'll call the parameter here new node, and that's going to be of type skill node as well. And all that we do here is we just, on event constructs, we want to make sure that our canvas panel is a variable. That way we can access it here in the code. And we just get all children. And then with all children, we for each loop over those. And we very simply just cast to our skill node to, number one, check whether or not an individual child is a skill node or not, because if it isn't, this cast is going to fail. But also because we need to get access to the event dispatcher on the skill node. Now, at the moment, it's only going to have one thing that's not a skill node, which is this background image as a child. But you might have other things inside of this that might also not be skill nodes. It doesn't really matter that much. It's only going to be running this once as well, so it shouldn't be too heavy, even though we are looping over every single child inside of the canvas panel. It's generally probably fine. Unless you literally have like tens of thousands of skill nodes within this thing, but at that point, you're going to run into other bottlenecks before this for each loop becomes an issue. Anyway, we loop over this skill node, and then we just assign to on node selected, which creates this binding node as well as a matching event. And now anytime any of the skill nodes within this tree get clicked on, this event here will run. And all that this event needs to do is it needs to just call out on new node selected. Just takes in the node that is given in and forwards it to whoever is listening. Now we have a singular event dispatcher to listen to for other widgets that might be trying to look for whatever node we most recently clicked on, instead of everything needing to subscribe to every single node, which can just kind of be a headache. So with all of that set up, it's a lot of setup, a lot of going back and forth between widgets here today, but now we have everything in place for clicking on the widget to update this widget info. So what this means is if we make sure that both of these are also variable, which they should be, and go into the event graph in the skill tree menu widget, if we have the skill tree selected, we now should have an event here on new node selected. That's the event dispatcher that we created. And whenever we select a new node, we can get our skill info and we can say, hey, update that skill info with whatever node was recently selected. So the chain of events that's going to happen here is we have a skill node that we click on that's going to emit a signal or a event dispatcher outward that's going to say, oh, this code actually here, that's going to say, hey, I'm just going to attach a reference to myself so that anybody listening out knows what button was just clicked on. Then the skill tree widget, which is going to be the thing housing all of our nodes, is going to be listening out to every single node inside of it. When it hears that signal that something has been clicked on, it has that reference of whatever node was clicked on giving through. And it itself doesn't really do anything with that. All that it does is it serves as a centralized location to forward that information to things that actually care about it. So it hears, oh, your button number 33 or whatever has been clicked on. Then this thing just shouts out, hey, this was the button that was most recently clicked on. And then our skill tree menu is just a thing that connects these two things. So whenever our skill tree has information about something new being clicked on, it just tells that to the skill info widget, which can then update all of its information accordingly. If we finally go back into my third-person blueprint here, and instead of adding the skill tree directly to the screen, as we've been doing before, I'm going to be adding our skill tree menu to the screen. And now we'll be able to see, if I click on one of these, it immediately updates and shows all of the stuff for it. If I now click on another one, it updates this. I apparently didn't update the description for this asset, but if the asset actually is well written, so in here I just have a issue where I didn't type the description properly. But now that that is fixed, we will see that if I go through, it actually shows everything whenever I click on one of these things. Which only leaves us with hooking up the unlocking button. And that itself also is super easy because we have this skill info widget, right? And inside of that skill info widget, we have our node that we're displaying already. So all that we need to do is whenever we click on this button, we already have that button as a variable. When we click on that, we just take our skill node that we're displaying. We first and foremost check whether or not that is valid. If it is valid, we can get the skill reference to the asset that is on that node, which again, we should check whether or not that is valid. And if that is both valid, we can just unlock skill to player, which once again, this thing might have a reference to the player itself. Eventually, as we get along with like unlocking stuff and all that kind of goodness, it likely will. But for now, we just add a player pawn or get player character node and just provide that in like this. And just as easily as that now, this is the widget that's going to be actually running the function that will unlock our, in this case, HP upgrades. So here you can see, I can click on this, and then when I click on unlock, that is when it actually updates my HP. Now, I can still infinitely keep unlocking this, and that is because we still don't have anything to keep track of which nodes have or have not been unlocked. That is coming very soon. The very first thing that we're going to be doing before that, though, is adding something to add in a cost for unlocking something. So we have a experience system or whatever that we can take experience or maybe gold or maybe items from to make sure that we can only unlock these things if we actually have whatever resources we need to unlock them. That's going to be next video though. For now, If you want the project files, I always keep every single episode of a series up to date with the project files as they are at that point in time for YouTube members and Patreons. Helps a lot to support the channel and helps you hopefully with exploring the code as it is being written. We have functioning nodes in our skill tree that aren't connected yet and also don't have costs yet, but we can unlock stuff and it increases, in this case, our HP. Now I want to look at doing this text block down here. We put that in the previous video, and that's going to be displaying the costs that we need to pay in order to unlock this node. And also going to allow us to check if we actually can pay that cost before unlocking the node to begin with. All in all, this is actually a relatively simple setup. So we're going to go into our skill tree folder, into our classes, and we're going to be making a new data asset class here. So we once again just go pick parent class, all classes, and we look for the data assets, picking the primary data assets, and we'll call that something like BP skill unlocker. And in this, we can add in a couple of functions. So the very first thing that we need to add in is can unlock skill. And this is just going to check whether or not our skill can actually be unlocked. So we give in certain information and then we output a bool value out of that. So we probably want to input some sort of player reference because we'll likely have to sample something from the player, be it experience, be it something like an item, whatever we want to do really. So let's just put in a pawn reference for the player there. And then in outputs, obviously, we want to see if we can unlock the skill. And that is going to be a type bool. Now, just like we did before, I'm going to actually put in a print string here, because this is never going to be called. This should never be called. This is only the placeholder for every other class that comes after this that's going to overwrite this with their own implementation. So I just very simply wrote a quick little thing here in my reference project. If you've seen the last video, this will be or the video before that actually, this will be very familiar with you. This is just going to print out in a red color, base unlocker class function call, can unlock skill, override function in class, and then it's going to print out the class that we accidentally called this on. Again, this is a function that never should be directly called, only there to be overwritten. And as such, we're going to go into the class settings here, just like we did before. And we're actually going to make this a abstract class so that we can't directly instantiate this. Again, this is only a class that's meant to have a template to make child classes of. Never should be directly instantiated as an asset. Then we can add a new function as well, which will be getUnlockText, and this will just be the text that we will display on screen to show what we need to unlock to our player. So that's going to potentially as well take in a player pawn. Maybe it doesn't even need to take in a player pawn, but you can do really whatever you want with that. I like just being able to give in the player, because if any of the things down the line, any of the children, for some reason need to get something from the player here, for the most part, especially in this unlock text, you probably won't need to, but it's good to have that, because you can't, when overriding something, then add in new parameters in the child versions of this. So you need to set up the potential parameters that the children might be needing to use, all within this parent class that we're working on right now. So that's going to be a pawn object reference, just like before. And of course, this is going to output a text. So we just put in text. And here as well, instead of doing a print string, because we don't really execute this is just going to be returning a value. We still want to return a default value of some kind of warning. So this is going to say base class override function to add cost text. And that's pretty much everything there is to this one. And finally, we can now check, or at least we have a function to check. We still need to write the override for it in a moment. But we can check whether or not we can unlock a skill. We can display that text. But now we also need to be able to apply the cost for unlocking a skill. Because if we say we use our experience as a currency, like in a Souls-like game, or maybe we want to be able to take away an item from an inventory to unlock certain things. Again, this is being used now in the context of a skill tree, but because this is all asset based, this is very much going to allow us to also use these same assets to maybe unlock things outside of the context of a skill tree and just in the world. You can make this skill unlocker be used by something like a door, which needs a certain key to enter, right? It's a very reusable type of system. So what we want to do is we want to have one more function, and that is apply unlock cost, which, to nobody's surprise, is going to take an input for the player. And that's going to be, I just make these all of type born so that they are as reusable as possible. You could make this just directly the type of class that your player is. You could make this a character. You could even make it more generic. You could just make this a general object so that you can give in specific data objects or whatever. That's entirely up to what you want to do. We're going to stick with born here because it is a good mix between being generic but not too generic. And much like the first function that we did here, I'm just going to copy over this set of nodes again, because we're going to be printing a string, base unlocker function call, apply unlock cost, override function in class, get class display name from get class from self. Again, this is not entirely necessary. This doesn't do anything aside from letting you know that you are calling a function that shouldn't be called. So that is the entire setup for making the base class. So again, we're not going to be using this one directly. So what we do is we come up to the class asset in our folder structure, and then we create a child blueprint of it. And we'll call this BP XP cost or something like that. And this is going to be the blueprint that we use for any amount of experience cost. So we can make different assets that represent costing 50 or 100 or 500 experience. Everything that's going to be costing experience is going to be a asset of this type. So with that, we want to override pretty much every single one of these functions that we just made. And we're not going to be wanting to call the parent functions because, again, those parent functions are not meant to actually run code. All they're meant to do is just be placeholders for something that is overridable. Because that way we can always just have references in our code to this base class, and then whatever the actual implementation is in whatever child class we're working with, that code will get run. So in this case, our player is going to need to have some sort of experience value. So let's go into our blueprints here, our blueprint character. And along with the HP value that I gave it a while ago, I'm going to just give it an experience value as well. It's also going to be a float. And let's just say that by default, we started off with having 1,000 experience, just so that we have something to spend as we test this system out. Back in the XP costs blueprint, now making sure that we've both compiled and saved the player actually, we can get the can unlock skill function, and we can cast our player reference to our BP third person character. And from there, we can get the XP value. So now we can figure out how much XP the player has in this asset. We need to compare that to the amount of XP that this asset will be representing. So we just check, hey, is our XP greater than or equal to? And we can then drag off of this and promote this to a variable, not a local variable, just a normal variable. I made a local variable before. And we'll call that something like XP needed, because it'll be the XP that we need to upgrade this. You can make that exposed if you want to. And that's pretty much all that we need. We need to know, is the XP that we have currently, is that more than the XP that we need for this asset? And that's then what we can return. If this cast fails, we're trying to provide in something that shouldn't be provided in. You can add in a print string here if you want to, telling you like, hey, cast failed in XP cost calculation. We're not going to do that right now. All we need to do is just return unlock being false, because obviously we gave in a type of object that's not worth checking, so most likely we don't want to allow that unlock. Next up is the can unlock skill text that'll do. And this is pretty easy. We don't even really need the reference to the player for this. Again, we just included that in case we need some information from the player in a different version of what this could do. But here, all that we really do is we can just make a literal text. And this is going to be a little bit weird because when we have texts, these are translatable, right? These work with Unreal's localization systems. We first want to put in the actual text here as a text. So let's call this just XP required. And then we need to put in a value, but we can't just append a other value to a text variable. So what we need to do first is we need to get this as a text. Then we need to translate this to a string, because when it is a string, we can append something to it. So we have XP required, and then we can append our XP needed value. So we drag that in, put that in, and then those will append into one singular string. And then that can translate back into a text for our return node. And lastly, once we know that we can unlock the skill, we need to apply the cost. Again, this might depend on whatever type of game you're making, but it's good to set up a basic system to allow for this, right? So we once again just cast to our third-person player character. We also are going to assume that this apply unlock cost only ever runs after the can unlock skill has already been successful, because that's the way that we're going to set up our code here. You could very much, of course, just run can unlock skill on this player first within this apply unlock cost as well, to make 1000% sure that what we're trying to do is actually possible. This is a little bit of extra security for that. It's up to you whether or not you want to put that in here. I'm not gonna, but it's not unreasonable to put that node in there as well. Anyway, we want to then set our XP value on our player to being its current XP value, so we get the XP value as well, minus the XP cost that we have from our XP needed. This just effectively, as you are used to updating like things like HP, anything, you just get its current value, subtract what you want to subtract, and that's going to be the new value. And that's everything we need here. Again, if you have an item system with an inventory or whatever, you can very much use this to call remove item from inventory. So now we have our XP costs class. We don't have any assets of it yet, so let's make a new folder here for organizational purposes, which we'll call unlock assets or unlocker assets, whatever you want to call that. And we'll just add 2 of them. You're going to go into miscellaneous, data assets, and there we can get our XP cost. Again, note that the base class for skill unlocker isn't available here because we made it abstract. We can only use the classes that are made of it. XP costs, we'll just call this costs 100 XP, and we open that up, and all that we need to fill in here is the XP cost for 100. Now, for a lot of skill tree systems, maybe you always want to just have XP cost of like certain types of resources, and you want to be able to just set that more easily on a per node basis instead of having a bunch of different assets that are pre-programmed to set up these things. You can still kind of twist this system to do something like that. The whole thing about this system is that it is very expandable. Because it is entirely asset-based, it means that you can very easily just make a new class here with new scripting that does new specific stuff, and then you can have a bunch of assets with different actual values for those. Downside being is that for every single variation of XP needed, you're more or less always going to be needing a new asset, which can be a little annoying if you have a whole lot of things that have slightly different values needed for unlocking. So it's by no means the perfect system. It just depends on whether or not you want something super straightforward or if you want something super scriptable and expandable. I tend to lean more towards the latter personally. But let's say that we also want one that unlocks at 250 XP. So all we need to do is we just need to make a new asset, give the value in as 250, and that's pretty much all there is to that. Now with that, we need to go back in, of course, and implement using these assets into our actual skill tree. So first things first, I think what we're going to do is we're going to go into our skill tree node. That's the most important part. And in our graph here, where we already have a skill to unlock asset reference, we also want to make a new variable with the unlocker assets. And that's very easily just going to be of type BP skill unlocker object reference. We expose that, and that's pretty much all that we need to do with this, because again, the skill nodes themselves actually don't really tend to run much code anymore. All that they do is just hold the information and the references to the things that matter. It's the other blueprints that we've been setting up that actually run all the code. So that's mostly done in this case through things like the skill info. So opening up that skill info, we can pretty much immediately go into our graph. If you've seen the last video, you should be up to date with everything that this does. And really all we need to do here is we already have our skill node that we're displaying the information from. So instead of just getting the stuff from skill to unlock, we now can also get our unlocker assets and very easily just get the unlock text from that. Now, get unlock text is a normal function. That really doesn't need to be the case. So if we double click on that, we can go back into the actual BP skill unlocker. And we can just click on either the input or the output node and mark it as being pure. It's really not that big a deal one way or the other. The only difference is that it becomes one of these little green nodes that doesn't have execution pins. The big difference there being is that a normal node with execution pins, the outputs get kind of locked into place at the moment of execution, where these green nodes just get rerun whenever an actual execution node calls their output pin. So we get this unlock text, and then I just need to look real quick which one of these we have the cost is what it is called, and we'll just set the text on that. So set text on this to whatever text this outputs, and then we probably want to, just to be sure, provide in a reference to the player. We can just do that from the get player pawn node. I'm just going to copy the one that we had down there. Again, we're not using that in this case, but in the future, whatever you're doing with your system, you might, and you just want this widget to actually provide that in, just in case. So now, just to make sure that everything that we have set up is working so far, let's go into our actual skill tree widgets and give in, this one's going to cost 100, this one's going to cost 250, and let's also make one that is just entirely free. So what we can do there is go back into our classes, and I'm going to just duplicate with Ctrl and D our XP cost, and we'll call this free unlock. And the reason that I'm making this different is just because what I want to do is apply unlock cost. I just want to make all of these empty, really. I don't really, I can always unlock this. Something that's free to unlock is always unlockable. And the unlock text is going to just be get it for free. Something like that. Of course, this unlock text, you can also just make a variable if you want to, so that you can set them on a per asset basis instead of needing to make an entirely new class for it. That way we could just say, hey, it takes 0 XP, and we give in a new text for it. That might be a little bit better, because now we made an entire class for something that's only going to have one asset in it, which might not be ideal. That's entirely up to what you want to do with it, but we can just make a BP free unlock now, and we'll call this cost free. And if we go back into the skill tree, we can set this last one up as being free. So let's see if everything we have set up actually works. I will add this thing to the viewport, and now we can see XP required 250. And here it is 100, and here it says get it for free. So all this works entirely from the display side of things. But now we also need to actually start checking if we have the required stuff for this. So that we also do in our skill info. This isn't just a skill info, because we also are handling the button input for actually unlocking the skills. So what we do here is in update skill info, first and foremost, we check if we have a skill node to display to begin with. But if we do, we set some information in it. We also are going to set whether or not this button, which we have a reference to in our variables here, we're going to set that being either enabled or disabled. And if we disable a button, it'll still be present, it'll still be visible, you just can't click on it. So all that we really need to do there is get our unlocking assets and check can unlock skill, which once again this is maybe okay to be a pure node. This one makes a little bit more sense to be a execution node, because you want to check in this moment, at this point in the execution flow, can we unlock it still? But if we can unlock it or not, that's going to be setting this button to being enabled or not. So set is enabled. That's just a thing that you can do with any widget, by the way. And if we can unlock, this will be enabled. And if we cannot unlock, this will be disabled. Now, this also very much means that if we click on something, we want to refresh the update info. Because after we click on something, we want to recheck if we still can unlock it. So we're going to be checking in the next video, then also whether this was already like granted or unlocked, so that we can only do one click per node. Because right now we can just spam the same node over and over again. Obviously, we don't want to be able to do that. But that's going to be in the next video. For now, all that we need to do is after we click on the button, we unlock skill to player, and then we just update skill info again. And we can just update the skill info and give in the same skill node that we already have. This is just refreshing it. And even before we do that, actually, we want to, because we are checking if we can unlock the skill, but we're never actually applying that cost. And we only want to do that once the button is clicked. So this is whenever we update the skill info, we're setting whether or not the skill can be unlocked, allowing the player to press the button or not. Then when the actual button is pressed, before we update the skill info to refresh it, what we want to do is we want to get our skill node that we're displaying and the unlock assets. And then we want to actually apply that unlock cost with the function that we set up. It's going to take in the player pawn as well. Now, if you have very specific potential implementations, you might want to first unlock and then apply cost, or first apply cost and then unlock. That should effectively be the same thing. These two things shouldn't really conflict with each other, but in very specific situations, depending on what you're making, the order here might be better swapped. And just to be thorough, what I'm also going to do here is in the actual skill tree menu, which I don't remember where that is. It's this one. I'm going to put in just a little text that's going to display the amount of experience that our player has. I'm going to do that fairly inefficiently. I'm just going to throw that into the tick event because it's just for demonstrational purposes. Obviously, you'd ideally only want to set the text and update it here when that value actually changes. But for the time being, this is just so that you can see what's going on. So get player pawn, we cast that to our third person character. We get the XP value, and that's just going to be the text that we set. Again, just so that we can see in the actual UI that our cost is getting applied. And of course, you do need to hook up the execution pins on the casting node. And now we will see. I can select any of these nodes, and this will cost 250. I've got 1,000. I click unlock. I've only got 750 left. And if I keep doing this with, let's say, just 100 at a time, if I go down to only having 150 left, now, when I click on this thing, you can see that this is grayed out. This is just what Unreal does when you disable a button. It grays it out, and I can no longer click on it. If I go back to this 100 XP required, you'll see if I click on this, I'll go under 100, I only have 50 left, and it's going to be refreshed because we're refreshing every time that we click on that button. And now this as well is disabled. This one, however, still, because it's entirely free, is going to allow me to infinitely unlock over and over and over again. So we've got our cost system set up now for these different skill nodes. If you want the current state of the project or the finished project, I always have the finished project on these ready as well. There's a link down below in the description to YouTube members and Patreons to snoop around in the code as we develop it. Now that we have many elements of our skill tree done, we have skills that we can unlock, we are upgrading our HP, and you can see we're also taking away some resource, XP, souls, whatever you want to call it, every time we unlock that. There's two more things that we really need to take a look at for the functionality here. And that is number one, only allowing every node to be unlocked once. And number two, hooking these up together to actually make them function as a tree where unlocking one node then makes nodes under it available. So that's what we're going to be doing here right now. Let's start by opening up the skill node widget itself, because these are going to need to have somewhat more code inside of it now. I'm going to set these up in a way where they have two bools, whether or not they are opened, which is going to mean just are they available to be unlocked, and whether or not they are already unlocked. So we'll make a bool called isOpen. Can make that exposed if you want to, because some of them you want to have opened as a default. Most of them won't be opened by default, of course. And then we also have isUnlocked. Now, you can name these whatever you want. If other names make more sense to you, of course. This is the way that makes sense to me. But unlocked might not. Now, in the previous video, we set up the unlocking of the actual skills, the checking of it, and then the granting of it. Inside this skill info widget. That's the thing that we saw on the right-hand side in our actual menu, this thing. And we're going to move that back into the actual skill node for a couple of different reasons. With this unlock skill to player, apply unlock cost, those things are actually going to move back into the skill node itself. There, what we'll do is we'll make a custom event, and we'll call that something like unlock skill. I already have a unlock skill event somewhere, apparently. Oh, I do. That's good. We're going to just work on this one, I guess. So at the moment, we're not using this anymore, but we'll come back to using this as we go along. So instead of just unlocking the skill to player, this will also now just use the unlocker asset to apply the unlock cost to the player as well. And the reason that we're moving this code back into this node now is because unlocking a skill is going to mean that this node is going to have some extra jobs as well. Mainly that being, of course, setting isUnlocked to being true now, because we want to mark this as now being unlocked so that we can no longer re-unlock it again. But we also want to make it open up all of the next nodes down the skill tree. So for that, we're going to first and foremost need a variable that's going to hold all of those nodes that are downstream from it. So what we do is we call that something like next nodes. And that's going to be of type WBP skill node. So it's going to be of the same type that this thing itself is, because it's going to be holding references to all the other nodes it is related to. And instead of just being one can be fine if it's just entirely like a linear path. We're going to make this an array though. And the reason that we do that is because one node might unlock 2 or 3 or 5 or a variable number of different nodes down the line. Now we'll come back to this unlock skill function in a moment, because I'm going to make a new function or event here, and we'll call that open children, just for organizational purposes. Effectively, this only ever happens with an unlock skill, but it's just nice to not have a super long event, just break up your code a little bit. We get our next nodes array here, and we for each loop over that. And then for all of those, all we really need to do is just call open node, which is going to be the next custom event that we make here. So we call this open node. And open node itself also doesn't do that much. All that it does, of course, is set our isOpen state. Effectively, we're always going to call this to set this to true, so you can just do this if you want to. If you, for whatever reason, want to be able to unopen a node by calling this event, which might at some point become relevant, it's good to just have that as a parameter instead. And then we want to make something visually different about this node so that it is visually obvious that it is now a unlockable state. It's opened up for us to be able to click on. So once again, we make a new custom event. We're going to go back up the chain in a moment. And we'll call this something like set node state. Set node state visual. Try to make your function and event names descriptive, if at all possible. For me, all that this really needs to do is it needs to get our icon and set it to a tint. So we can brush tint this, set brush tint color, and we can use a select node for this. And we're just going to check, hey, is this thing opened? If it is not opened, we're going to be making a slate color. And the slate color that's going to be used here is just going to be like a like 60% gray or something like that. Something dark, and just making sure that it's visually obvious that this is inactive at the moment. And if it is true, we just want to set the tint to being white. And then after that, we check if we are unlocked or not. You can do this by just converting this to branch by right-clicking on it, or alternatively, you can just hook it up to a branch if you prefer that. And this will just set the color for our button itself. So our button, we set the background color on that. And I'm just going to set the background color for the button itself to be like blue if it has been unlocked. So this will do the styling for both if it is unlockable and if it is unlocked. The image icon itself will show whether or not it is unlockable. And then the background color for the button will show whether or not we have previously unlocked it. So that's everything to do with making new custom events that are going to be called in other custom events and so on and so forth. So we can go back up the chain now. After we open a node, we can then try to set the node visual state. And in open children, we just go over all of the things that are in the next nodes array, and we just open node. And in this case, we just set them open true. Again, pretty much always we're going to be setting open to true. I can't see that many situations where you want to close a node after it has been opened. But it is, again, just good to have the capability of doing that. Don't hard code things too much. And then we finally get back to our unlock skill event. So after we've unlocked this skill, we just open the children of this thing, and that pretty much gets us everything we really need to have the skill tree progression. Now, we want to go back one step real quick here as well into event construct, because on event construct, we also want to set the node's visual state, so that when they get added to the screen, they get checked, hey, am I unlockable or not? And based on that, they will update their looks immediately. We don't need event tick, so let's delete that. We just set node state visual on event construct. So now if we open up our node thing, we see that all the icons are grayed out. So that's a good start. But we, of course, want one of the icons to not start grayed out. So let's actually rearrange these into a way that kind of makes sense. And then I will also copy a couple extra ones over here. So what we're going to do is this one is going to unlock these two, and this one is going to unlock these two. I want to make one very clear warning here, though. And that is if I can overlay some footage of the skill tree in my own game, the thing that I developed this system for in the first place. The thing that I have there is it's more of a skill web than a skill tree, and that will quickly start being an issue. And the reason that that starts being an issue is because if you make these references go around in a loop, the widget editor specifically doesn't like that. On runtime, it's fine. It's just within the widget editor itself, whenever you click on one of these nodes, what it does is it tries to load in every single node that it references. And it does that in a recursive way. So if I click on this, it tries to load in these two. And then if these two are trying to be loaded in, those have references and it tries to load in these two as well. That's actually not that much of a problem, believe it or not. Even if you have like 100, 200 nodes in a tree, widget editor kind of like powers through that. It's not that big of a deal because they're all going to be loaded during runtime anyway, right? So they're not actually that big. The problem comes in where if I add in a couple extra ones like this, if this one then references this one, and this one references this one, and this one references back to this one, I've now created a loop of references, and the widget editor is not really built to deal with that, it turns out. The moment you start doing this, especially if your tree is relatively big and it's got multiple of these loops inside of it, clicking on any given widget within that loop will make your editor stall for anywhere between like 30 to 90 seconds every time you click on one thing inside of that loop. So do be mindful of the fact that you shouldn't build these to loop around. If you do want to build a skill tree that can loop around in on itself in some ways, you might need to build a different tool to actually build out the skill tree instead of building it out within the actual widget editor that Unreal gives you. If you just have a fairly linear tree that doesn't have any of this looping, that's not an issue. I just want to make sure to warn you, looping these things back in on themselves is gonna potentially be an issue. So anyway, let's set up these next nodes. So we have this array here in all of our nodes. And in this case, I can just say this node is going to connect to these two. And it does that based on name. So do make sure that they have been given unique new names. If you just drag in a skill tree node like this, it's going to usually have a default name. And it might not show up in this drop-down menu here. In this case, it actually does. So maybe that has been fixed in a recent version of Unreal. But I've had issues in the past where these drop-down menus don't show certain widgets because they haven't been given a unique name yet. Speaking of unique names, it's good to just name these so that you can actually see which one is which. So let's call this add 5 HP tier 1. And this will be our starting node. This will be add 10 HP tier 2. And then this will be add 10 HP tier 3. And this one will be add 5 HP tier 3. I'm just calling these tier 1, 2, 3 because this will be on layer 1, layer 2, layer 3. This is just temporary names, of course. And then just to have this be thorough, I want to change this to actually being the right data asset as well. So this one will connect up to both of the tier 2 ones. So this one will be tier 2 and, well, actually, that's tier 1. I misnamed them. This is tier 2. Starting would be tier 1. My bad there. So this connects up to both of those. This connects up to nothing at the moment. And this one will connect up to both of the tier 3 nodes. And then all we need to do is we need to make sure that this first one is by default set to being open so that we can actually interact with it. So with that, we can open this up and we can see this one is unlockable. And whenever I unlock this, it actually does make these other ones unlockable. There's one thing that I skipped over though, that the skill info is still running somewhat of the wrong code. So let me just put that up right here. And there on the button clicked, we're still doing this skill node display, skill node unlock, and then we're doing all the unlocking code through here, right? So what we want to do instead is this unlock skill to player and apply unlock cost. We're going to get rid of that within the skill info. And then the skill node display is going to just run the unlock skill event that it has inside of itself. And now you will see that if we unlock this, it actually unlocks the things below it. And then when we unlock this, it unlocks the things below it. We still have the issue where the background color doesn't properly change whenever we unlock the skill. And that seems to simply be because I forgot to add a simple little node. So back in the skill node widget, which is this one, if we go back to unlock skill, at the very end of all of this, after we've set is unlocked true, after we've opened the children, we also want to just set the node visuals for this node itself. And that'll immediately show you that it now does properly update when we click on these. Now, we can still double, triple, quadruple unlock these, which is obviously something we don't want to be able to do. But at this point, that's actually super easy to figure out because we've got the 2 extra variables we need for that already set up. So if we just go back into the skill info, you might recall that what we do here is whenever we update the skill info, we are setting the button to being enabled or disabled based on whether or not we can unlock the skill. All we need to do is, instead of just checking, hey, can we unlock the skill, we also need to check, hey, is this node already opened up and is this node already unlocked? So we pull off of this can unlock and then we put that into an AND boolean and just give that 3 inputs. Only if all 3 of these inputs are true is this output going to be true. So the other 2 inputs are going to be from our skill node to display. We want to check get is open. We only want to be able to click on the unlock button if the node has been opened up. And we also want to get is unlocked, but this is the wrong value, right? This is the wrong way around. This will be true if we already have unlocked it. It will be false if we haven't yet unlocked it. So we want the inverse of this, which we can just do by getting a not boolean. This just inverts the value from true to false or from false to true. So now what this is doing is it's checking, hey, can I unlock the skill? And is the skill node open? And is the skill not yet unlocked? Only if all three are true will this be disabled. If any of these three checks ends up being false, the entire end node will output a false. And that's literally everything there is to making skills only unlockable once. So now we will see that it immediately disables this button for me after I've clicked on it once. If I click off of it and back onto it, I can't re-unlock this, and everything is only unlockable once. So we effectively now have the entire skill tree functioning from a code perspective. But immediately, there's a couple of different issues. Number one, we need to be able to save this state so that when we close this widget and reopen it, or even better, when we stop playing the game and reload our save file, this all gets remembered. And it's super not clear which things connect up to what. We need to draw lines between all the connected nodes. And we need to be able to pan and zoom in and out these widgets, because you can already see that some of the widgets are getting cut off. And as you build a big skill tree, it's not all going to fit on screen at once. So there's a couple more videos coming, but from a coding perspective, we've pretty much done the hard part at this point. Next time, let's focus on drawing those lines. Our skill tree isn't much of a skill tree if we don't have the skills visually connecting to each other. So let's work on something that, instead of having to set up images to connect everything manually, because that's going to be a hell to do, we want to connect these up automatically. In the last video, we already set up a system where every node has a list of references to nodes that it needs to connect to. So all that we need to do at this point is take this list of nodes in each one, which I'm trying to find the right widget. There we go. Take this list of nodes and just say, hey, draw a line from this node to that node, and from this node to that node. That's pretty much as simple as it is. But how do we do that? Well, if we're here in our actual skill tree widget, you might remember that at some point in the past, we added this image in here. Also, now that we're working more and more on this skill tree widget itself, you might also notice that if you scroll away and you don't have the actual bounds of our desired on screen or our fill screen, like this dotted line on screen anymore, everything inside of it kind of just stops rendering at some point. The way to kind of change that around is just to set this to desired. So that way our dotted line will expand to fill its entire content. So now everything will always just render no matter how far we like pan or scroll away. Anyway, this image is what we are going to be working on, because we have got this background image that I put in just so that we have a clear edge to our skill tree widget. This image is going to be replaced by an image that's also going to be drawing the lines on top of itself. So Unreal actually has a built-in handful of functions that can let you draw lines in your UI widgets. The issue, though, is that those draw always on top. So we can't do it within this widget, because what would happen if we did it here is it would draw the lines all the way on top of everything else. So we have the line going from here to here over top of our nodes. We don't want that. So we're going to be making a separate widget that we give in the positions of all the lines that we want to draw. That widget is going to be taking the place of this image. And then that is going to draw all the lines on top of itself. And then all the nodes in the skill tree will be drawn over top of those. That ends up being a little bit janky in some ways, but it makes the math a lot easier than having to offset every line into certain directions based on angles and that kind of stuff. So what we'll do is I will go in here, I make a new widget, blueprint, user widgets, and I'll call that WBP line drawer. If we open that up, what I'm going to put in here is I'm going to still put in an image for the background color. We'll set the color and opacity for this to being a similar like dull gray, maybe make it a little bit blue, just to make it a little bit more pleasant. And there's nothing else going to be in here in terms of widgets. We just immediately dive into the code. Now, in here, we want to make an array. And you can see I already have a draw spline here. I've been trying to like figure out a couple of different things. We have a whole bunch of just drawing information structs in Unreal. You can probably use one of the draw line ones. We've got like this debug line and then draws a line in the viewport given a start and end. And then we also have another one of those. The thing is, these are part of the unit debug line system. So I'm not 1000% sure that these will show up properly in your packaged builds, because these are usually used by the debugging tools. The struct itself might not be available outside of development and in editor builds. So what we're going to be doing instead, just to be sure, is I'm going to make my own struct with the information that we care about. We have this struct that we make in just blueprint structs. We'll call it str line to draw. And there we can give in the starting point. So we can call that point A. Since we're only doing this within the widget within our UI, we only need this to be two-dimensional. So we can do a vector 2D. And then, of course, we also need a point B. And the reason that we're doing this in a custom struct is because now we can also give in something like the thickness of said line. So it'll be a float, and we can give in the color of the line as well. And that'll be a linear color, or maybe just slate color. I think linear color should be fine. And with that made, we can come back into the variable that we just made, give it a name as well. I thought I did that, but I didn't. Lines to draw. And we can make that of our new type line to draw. You'll see that we have all of the information that we want to give in there. Of course, array important because we're going to be drawing a lot of lines. We'll set the value for this in a moment because we're going to be setting the value for this from our actual skill tree widget itself. We're going to be giving this in. But before we go back there, let's just finish up this part of the system first. So we're going to override a function, and the function that we'll override is onPaint. onPaint is the function that you use to draw in extra primitive shapes, like boxes, lines in this case. I believe it might even be like drawing circles and that kind of stuff for your widgets. It gives you in the paint context that you need to actually run those functions. So what we do is we get our lines to draw. There we for each loop over the entire array. So for every single one of the lines in this array, we're going to be drawing, well, who would have guessed it, a line. We simply draw a line, and you don't mistype it. So you can see here we've got draw box, draw line, draw lines. You might think that you want to draw lines instead of just draw line. The difference here is this draws a single line. This draws multiple lines that are connected to each other. But since we don't have one continuous line that we want to draw, we want to have split parts in our lines, we're going to be drawing them individually instead. You can also draw a spline and some text. We've got some debug stuff here. I think this is all for 3D, and this is all for painting. This is for UI 2D. So we're going to be doing a draw line. That needs to take in a painting context, which is why we do this in onPaint. And then we give in a position A, a position B, a tint, and a thickness, and whether or not it should anti-alias. And the great thing is, we just make that struct that has all that information inside of it. Now, there is one catch to it. We can't just put this through one-to-one, because this is going to be a little bit annoying. But we're going to be putting this into our skill tree offset by half its size. It's going to be anchored to its center. If we go back to the skill tree right here, you will see, can I zoom this out anymore? No. But we've made this thing 15,000 by 15,000 units. I'm just going to make this like 5,000 by 5,000 instead, so that it's a little easier to fit on screen. Its alignment is 0.5, 0.5. If the alignment were just 0, 0, we would have it outline from the top left and just 5,000 extended away in the right and down directions. We want it to be aligned to the center, so that if we make it bigger, it grows in every direction. So it is aligned to 0.5, 0.5. Our line drawer is going to be the same way. The coordinates that we give in need to not draw from this point, which it will do by default. it will need to take in the coordinates of these things and then add the half size of the actual background to it so that it properly draws the coordinates from its actual origin point. That doesn't make sense. Just follow along and hopefully it'll start making sense in a moment. So the way that we set that up is we need to get the actual size of how big this thing is. We can do that in a number of different ways. The way that you usually use for things is getting the cached geometry. Since this is going to be on a canvas panel, what you could technically do as well is get slot as canvas slot, and you can just get a reference to self in it, and this will have a get size. This oftentimes will also work, but this only works when things are actually inside of a canvas slot. So it's a good habit to get into, to try to use cached geometry wherever possible, because this even works when you're not inside of a canvas. Anyway, we try to get the local size of this thing, and that's just going to tell us, okay, how big is this thing in the context to its parent. And since we want to offset our x and y coordinates for both the A point and the B point by half the size of this square or rectangle, all we need to do here is really divide this by, just to make this easy afloat, divide it by 2. So if this thing is 10,000 units wide and high, this is going to output 5,000, which is exactly the offset that we need. So then we just take out point A and we add that offset to it. That is what we're going to be putting into our position A. And the same with point B. We just add that offset to it and we put that into position B. Then we can just pull through the tint as the color and the thickness as the thickness. And that should pretty much be all there is to it. Now, at the end of this, it is good to just hook up the completed to the return node. And that's everything the line drawer itself needs to do. Constructing the lines for this array is going to be a little bit more involved. Let's immediately just move on over to that. Back in the skill tree, what we're going to do is I'm going to remove the background image that we've been using so far, because we're going to be replacing that with our new line drawer. So if we just do a line drawer, and we make sure that that's the first thing in our stack, because widgets render from bottom to top, so it renders this first and everything under it gets rendered after it. I need to figure out where this thing is, first and foremost. We align this to the center, and we set the alignment to being 50% and 50%, and then we set this back to the same size that we had before, which I think was about 5,000 by 5,000. Sometimes it's a little tricky to find these things in your widget view after you've changed the size. You can, of course, try to figure out where it is based on these coordinates up here. If you really can't find it, you just close it, and then you reopen it. So if I reopen it, it just reopens it centered on there. So there we go. And now we've got this line drawer here. So make sure that that's variable, and we can go into the graph view for the skill tree widgets. And here we'll make a new function, and that'll be get lines to draw. This is going to be returning an array of lines that needs to be drawn. Let's add in an output, and this will be lines to draw, which will of course be of type lines or line to draw, I think we called it. Yeah, that struct that we made. And that's going to be an array. We're going to construct this array within this function. So the way that we usually do those things is you just return a local variable. Let's call that local lines. This way, you can be sure that every time you enter this function, it just makes a new fresh version of this array. And you can just populate this array one thing at a time. And then at the end of the function, you just return the array that you've constructed. Now, how do we get every single line between every single one of these nodes? This is the difficult, this is the tricky part, right? We already have a reference to our canvas panel in here from a previous video. If you've skipped over that, you shouldn't do that. But you can go back into the designer here, make sure that the canvas panel is selected, and check whether or not it is variable. By default, it won't be, but because we've already used this as a variable in code before, I've already set it to variable. We get that as a reference, and then we get all children. There, we're going to for each loop over those. Now, every child of this, pretty much in all cases, aside from the line drawer itself, is going to just be our skill tree nodes. If you have anything else within here, that's not really a problem. Because the next thing that we're going to do is we need to cast this to our skill node anyway, because we're going to be getting some information out of the skill node, namely that being which nodes it's connected to. So we need to do this cast anyway. This also immediately functions as being a filter. So we get the next nodes, and there we, once again, for each loop. Do be mindful that whenever we are trying to get all the lines to draw, we're going to be looping over our entire array of nodes, and every one of those is going to be looping over the array of nodes that it is connected to. So if you have a very big tree, this might end up getting fairly expensive. You might only want to update this whenever you actually know that something has been updated. If you're not doing anything regarding updating the color or the thickness of your lines, really the only time that you need to run this would be on event construct, because the lines themselves aren't going to be changing between the nodes. That would be preferable. If you do want to dynamically change the colors or the thickness of the lines, ideally only run this get lines to draw thing whenever you actually know something has been updated. Don't just throw this into event tick. This will add up fairly quickly. Even though the actual operations that we're going to be doing aren't going to be that expensive, all that we need to do is we need to get our local array that we made, and we need to just add something to it. We'll just split this structure up in. We need to add a point A, a point B, a thickness, and a color. And how do we decide all those? Well, that's going to be the trick, isn't it? I'm just going to set thickness to 2 for every single one of these. Let's focus on the point A and point B first, and then we'll finish off with the color. The color is going to be fairly straightforward. The point A is going to be coming from the first thing in the loop here. So that's going to be coming from our cast to skill node. And if you think back to one of the first videos in this series where I said, well, we're going to be putting our skill tree within a canvas. There's 2 reasons for that. It allows us to easily put these things in whatever order we want, wherever we want, in whatever shape we want. That's the main thing, because you could render them with a different offsets in a overlay if you really wanted to and that kind of stuff. This is the other side of that, is because if we have a canvas slot that simply has a very easy just get position node, which gets us the XY position of any given node that we're working with. So this is going to get us the top left of all of those. There's 2 different things that we can do about that. Is we can either go through every single one of these nodes and make sure that they are much like the actual line drawer itself, aligned to being 0.5, 0.5. This will make that pivot point their center. So it'll regard their position as being calculated from here instead of from there. That is fine. That is a good way to do it. It might become tedious to have to do that for every single one that you add, though. And there's no real other benefit generally to doing that. And if you miss one, it's going to be weird. It's going to look ugly. So what you do instead is we get the desired size of the widgets. The desired size is just how big do I want to be? And in this case, note that we set up here, we set that to size to content. So this is always going to be forced to be at its desired size anyway. So the desired size should do everything that you need it to do. Then, again, very much the same as we did before. We need to divide that size by 2, because the size is the, well, size as a whole. If we divide the size, we just get the middle point. Adding these 2 things together gets us the middle point of our widget in the parent screen space. So we put that as point A. And then pretty much point B is going to be this exact same bit of code. So what you could do is you could collapse this to a function, collapse to function, and we call this something like get node position. And if we open that up, these are both going to be the same reference. So we can delete the second one here, call the input node, and the return value position. And let's make that pure as well, so that it doesn't have the execution pins. So we just get the node positions from the skill node, And then we get the node position for each one of the nodes that it is connected to for point B. And then we only have the color left. And the color, we really need to just check, hey, is this node that we're going to go toward, is it open, which is a value that we made last time. So we get is open, and we just add a select color node here, and then we just put this is open in here. And then if it is open, we probably want this to just be white. And if it is not open, we probably want this to be like a dark gray type of color. And we just do that for every connected node, for every node in the canvas panel. And then once this first for each loop has completed, so if you're playing along here, do pay attention to the fact that this is a return node after the first for each loop, not after this one. So what this is going to do is it's going to do this loop for every single one inside of this loop. Only when the outermost loop is completed do we return. We return the array that we've constructed, one thing at a time, over here. Now, in the event graph, you can on-construct. I like doing it on pre-construct, so it also shows in the editor. You can just get lines to draw, that function that we just made. And all then we need to do is we get our line drawer and we set our lines to draw to the output from that function. Now, again, this might be collapsed into a single function where we can just call this all at once, where we can just collapse to function, updates node lines, because you might want to call this at a later date. Write a little bit of code for that in a moment. But as you can see right now, it's writing the code for everything. But as you can see, it is going from top left to top left, so that's not ideal. What you might need to do if this ends up happening is you are not actually giving in the desired size properly, because it doesn't have a desired size yet. The way to fix that is to go into the skill node itself, so this widget over here, and there on pre-construct, what we may need to do is we need to force layout pre-pass. This just makes it render its geometry once so that it actually has geometry to sample from and know what its desired size is. And you see immediately then everything is linked up properly now. So yeah, that's pretty much everything there is to making these lines. So if we now just open this up, we can see if I unlock this, the lines don't update yet because we only set these lines up once. So now every time we unlock something, we want to be able to, in our skill tree widget, update our lines to draw array as well. So there we just need to make sure that every time we click on either new node selected, or what's actually probably better is if we go into our skill info. I'm kind of improvising here because this is not in my initial test project. But if we go into our skill info, we probably just want to have a event dispatcher linked to whenever we try to unlock a skill. So event dispatcher here, new skill unlocked. And whenever we have a new skill unlocked, it doesn't need to go through and send any information. It just needs to say, hey, a new skill was just unlocked. You probably want to update a bunch of stuff with your lines. So now that we have that, we can go back into the skill tree, because we already have our or skill tree menu rather. So this one, where both of these widgets exist side by side. Because here we have our skill tree info, and there we now have the new skill unlocked event that we can run any code on. So we get our skill tree, and there we just update, if we can spell it properly, update node lines whenever we unlock a new skill. And that should then update the node lines as we unlock skills. So you can see I've unlocked this one now. The line going to this one and this one is now white, and so on and so forth. So that's everything to do with the line drawer. It's pretty straightforward. You just need to really know that this is a thing that you can do in the Paint event. And with that, it's starting to look like an actual skill tree, which is fantastic. A little bit of code left to do, which is saving this stuff, fairly important, and then being able to pan and zoom in and out over it. So we're getting there. 2 more videos to go, and then we'll be In the meantime, if you want the project file in its current state or the finished project file with those things implemented, you can check out the link down below for YouTube members and patrons if you really can't wait to see the final parts of how this comes together. Even with a effectively functioning skill tree now, we can unlock skills, we have everything visual, it costs stuff to unlock skills, that's all good. But if I add in one thing, everything will break apart. So let's add in the thing that will ruin your life. We're going to add a button to our skill tree menu, and I'm going to put that right here. Let's anchor that to the bottom left as well, and I put in a text there because a button is kind of worthless if you don't know what it's going to do, and we'll call this quit. It's just going to remove this thing from the viewport, and you can kind of see where this is going, I'm sure. But if we just click on button 0 at a click event, what's that going to do? Well, what that's going to do is it's going to get the player controller and give back input to it. So set input mode to game only. It's going to show mouse cursor back to false. And then it's going to remove this widget itself from the viewport. So we just remove from parent. What happens when we do that? Well, we obviously get back our control. That's good. But let's unlock a couple of skills. Let's unlock these two, and then, oh, actually, we're going to do some gameplay, fight some monsters, we have some more experience, all that good. Okay, let's open up the skill tree again. Oh, it's back to default. Because obviously, if we remove the skill tree and then add it back in, it's going to add an entirely new blank instance of it. So every time we add this to the viewport, we need to be able to get the data of everything being unlocked or not unlocked from somewhere else. And since we need to put all that into this save file for our game as well, the best way to do this is to just put this into a save object, and then the save object can just be saved and loaded whenever we like. So let's take a look at that. All things considered, it's fairly easy to set that up, to just program this on top of what we already have. So if we go into the skill tree node itself, all we need to do is add an ID to this. Then what we can do is we can save the IDs of everything that has been unlocked. And then whenever we spawn in one of these nodes, we just check, hey, is this in a list of unlocked IDs? If so, we just forcefully unlock it by effectively just running this unlock skill, minus the unlocking it to the player and applying the cost, of course. So we just do this part of it. So how does the ID system work? Well, we'll make a node ID variable, and that'll be of type GUID. This is a global unique identifier, and every node is going to have its own global unique identifier. So after we've made that, compiled it, saved it, we need to go into the skill tree itself, and this is something that you do need to be mindful of. Every single one of these now has a node ID. You can just click on it, generate a new one, and Unreal automatically generates you an ID that hasn't been used anywhere else in your project yet. There's a very large pool of IDs to use. So don't worry about this running out of IDs that you can use, because there's no way that you're going to have enough objects in your skill tree, but even in your entire game, to fill out every ID that is possible with the GUID system. So you can pretty much use this as much and everywhere that you want to. So every single one of these is going to need to have a GUID. For normal actors, when you use this, generally what you do is you put a GUID check, whether or not it's valid or not, in its construction script. And if it is not a valid GUID, you make it auto-generate just a new one. You can't do that in widgets, because anything that you run on its pre-construct doesn't actually get applied properly. Just a quirk of how the widget system works, you do need to manually do this. The reason that you need to be mindful of this is if you're in the same habit that I am, and that is instead of pulling in new widgets from your palette and just clicking on one of these and copying it over, it's going to have the same GUID. So if you do that, you do need to generate a new one. And now that we have a new one anyway, we might as well, I guess, link this one up to that one. And again, compile this, we can see it immediately draws a line. How nice. So everything now has a GUID, a unique way to identify each given node. Now we just need to be able to keep track of which nodes have been saved and which ones haven't been. So for that, I'm going to make a new blueprint class here, and that will be a save game object. I'll call that BP skill tree save. You might, and you likely even, would actually want to implement this within the normal save game object that your game has. You probably only have one save game object for your entire game. And that's going to have just one variable in our case, and that's going to be the unlocked skill tree nodes. And that's just going to keep track of the GUIDs that have been unlocked. Of course, there's going to be an array, because it's going to be more than one. And what we do with this is we just keep a instance of this save object just kind of live around on one of our other objects, so that we can easily read and write to it without needing to actually commit it to being saved or loaded as like a save slot. If you want more information about that, I actually made a video about this entire concept, the difference between in-memory objects and on-disk objects, which I will try to remember to leave a link to in the pinned comment, maybe in the card aisle, wherever. If there's nothing that you can find, scream at me in the comments and I will link you to it. But the basic idea being is that in some sort of pretty persistent object, usually you would do that in the game instance. I'm not going to bother setting up an entire game instance for this, as well as the fact that the version of Unreal that I'm on has some issues opening in the project settings, so I can't even change the game instance, which is a little annoying. So we're just going to do this in the third-person character itself. Just usually, again, you do this in the game instance. So we just add in a begin play. In the game instance, it's what we call init. And there we just create save game object. And that save game object will be of type skill tree save. And we just keep that as our skill tree save object. Now I'm going to add a couple of debug keys. Debug key for L is going to be for loading our save from disk into this object. And then debug key P, I ideally do S, but that's already part of WASD, just because it's close to L, is going to be saving whatever is in this to a save slot on disk. So we get our save object here, and then L will be load. So we load save game from slots. What you'll probably want to do actually is does save game exist? And there we just, for now, we're going to give in a hard-coded variable name, which we'll just call skill tree. So we first check if skill tree already exists, because if it doesn't exist yet, we don't want to load it. Only if this actually exists on disk do we want to load it. And after we've loaded it, we cast it to the skill tree save, because loading a game from slot always gives you a generic save game object reference. And you can't hook that up to this specific one, so you need to cast it first. And then we will have loaded in our save file. So we get from disk, put it into the live object in memory, and all the code that we're going to be writing to check whether or not things have been unlocked or not are just going to be looking at this object reference. So that's the way that these more flexible save systems tend to work. All the way around, P is going to be saving this stuff, and this is going to be much easier because we can just save game to slots. The save game object is going to be our skill tree object save, and we just need to give in the same name, which is our skill tree. This is the saving and the loading part of it, and setting up the actual object. So once again, this usually exists in the game instance, not on your player character. With that little bit of setup, we can go back into the skill node widget, and this is going to look at that data that we just set up and decide whether or not it is pre-unlocked or not. So in event constructs, what I'll do is I'll actually put in a sequence node, because I want to set the node state visual after everything else that's going to be happening here. We get the player pawn. Again, usually you'll probably be getting the game instance here and casting that to your own game instance class, which is going to be, in our case, we're going to be casting it to the player character class. And there we get our save game objects. From there, we just get our unlocked skill trees and we check, hey, does this array contain the ID for this specific node? Because based on that, we can know, was this previously unlocked or not? Put that into a branch, and if that is the case, we just set this to being both opened and unlocked. Just hard-coded set those to being true. And then we bring that into another branch where we just check if it's unlocked. Both of these parts are going to be joining back together through this node. Now, if we've gone through this part, this will always be unlocked true, of course. If we've gone through this path, it still might end up being true if we like default unlock something or whatever. So that's the reason that we're checking something that we've literally just set. It's kind of just to recombine the execution flow into a single path. But if this has indeed been unlocked, we want to open its children. Now, it's going to do this for every node. So everything that is already opened and unlocked is going to get itself set to being opened multiple times, but that's not really an issue. But this way, we have a persistent way to keep track of which ones have been unlocked. And then all we need to do is whenever we unlock our skill, we need to also get our player pawn or instance and cast it, get our save tree object and the array inside of it and all that kind of good stuff. And what we need to do is in our unlock skill, just at the very end, also add to this. But we want to add unique so that we don't add the same GUID multiple times. Doesn't really break any part of the code, but it's just kind of worthless to have the same ID multiple times in the list. Not that big of a value to store multiple times, but you'd rather just not, right? So we added unique, the node ID for this node. So that way it gets added to this array on this object. And now we have a persistent object that's going to be keeping track of which ones have been unlocked and which ones have not been unlocked in the skill tree. And just as easily as that, we can open this up, unlock a couple of things, close it down, open it back up, and you can see everything persists. Now, I can even press the P key to save it, close out of the game, reopen it. We can see if I reopen it, obviously everything is back to default. Pressing the L key will now load everything back in, and you can see we have a functioning save system. So we're using the same code here to persist the data between opening of the widget and closing it. But then immediately we can also use it to function as the actual save system for our save games. So those two things immediately integrate because they're essentially the same thing. It's just one of them remembers it just in memory in an object, and the other one has to remember it by also writing it to disk. So next time, let's take a look at actually making this skill widget zoomable and pannable, because right now it still is static and we've got things that we can barely even click on and all that kind of stuff. So yeah, next time we're going to make this actually navigable and then we'll have an entirely working skill tree. Now, if you want the code for this, as always, link down below in the description. YouTube members and patrons can download project files on a per episode basis or for the entire course. Just a single month of subscription to either YouTube members or Patreon gets you access to every project that I've ever uploaded for the month that you're subscribed for. It does also help me out, supporting me making these longer form, more in-depth courses a lot. In today's video, we're going to be making a canvas that can zoom in and out based on where your cursor is, as well as let you pan around inside of it. The contents of which are going to be the skill tree that I've been working on in this skill tree series, but you don't really need to follow along with any of that in order for this video to work. This is purely going to be about zooming and panning your canvas. So as a basic setup of what we have already done before, so that you know what we're doing, is I have this menu here that contains a sub-widget. The sub-widget is just aligned with all of its corners to however big it is, so that it stretches properly on different aspect ratios and all that kind of stuff. We're not really going to be doing anything within this skill tree widget menu. So then we go over into the skill tree itself, and this is a canvas panel. Now, do pay in mind that the fact that this is a canvas panel and we're going to be putting it within another canvas panel here means that you probably don't want to instantiate hundreds or even many tens of these because canvas panels are somewhat more expensive to render. Theoretically, everything that we're going to be doing here should be doable with an overlay as well. We're just using a canvas panel. So in whatever panning widgets you want to have, it's probably good to actually make this a parent class that you can put other things inside of. What we're going to do is we're going to go over to the event graph and there, just ignore everything that's in here already. Again, that's all skill tree related. What we're going to do is we add in a handful of function overrides here. So we want to add in on mouse down. So that is on mouse button down. We want to add in on mouse button up, on mouse move, and then finally on mouse wheel, because we're going to be using the mouse wheel to zoom in and out. And then you probably also want to make a on mouse leave real quick. That's going to be an event, not a function. And the reason that we do this is because if we ever leave while trying to drag around, we want to tell the widget to stop dragging because it will no longer recognize the mouse up event if we're not over it. All the mouse clicks and ups and downs are just going to effectively be setting this value here, which is whether or not we are dragging our widget right now. So if the mouse ever leaves our widget, we obviously set that immediately to we're no longer dragging. And then we can go in to the mouse functions here. We do mouse button down, and there we check the mouse event. We get the affecting button, and we check whether or not that is the button that we want to use for dragging stuff around. So this could be the left mouse button, this could be the right mouse button, it could even be the middle mouse button. I'm going to go for the right mouse button in this case. If you want multiple things to be able to drag around, you can also just check multiple things. So right or middle mouse, and then just put this into an or boolean so that either one of these will work. If the mouse button that is being pressed down is actually one of these now, what we will do is we will set dragging, again, the variable that we just made, to being true. So we just put that in there, hook everything up like this. And then it is important to actually tell the return node here that this input event has now been handled, so that it knows that it doesn't need to do anything else after this with his inputs. And we're actually just going to copy over all this stuff here because the mouse button up is pretty much going to do the same thing. It's just going to check, hey, is the mouse button that we are affecting, so mouse event goes into there, is that the right mouse button or the middle mouse button? If so, dragging will be set to false instead. And then we want to return handled. All that just to keep track of whether or not we currently want to be dragging around our widgets. So let's do the dragging around first, and then we'll do the zooming in and out afterwards. So dragging around is done in the on mouse move function. And here it's important that our canvas panel inside of our designer, or at least whatever is the topmost thing that we're working with, has its variability set to is variable. If you're using a canvas panel, by default, it will not be variable. So you want to check this tick box to make it a variable, because we're going to be using the reference to it in our code. We get our canvas panel, and we get its transform. That's going to be a struct, one of those dark blue things. We split the structure bin, because what we're going to want to do is we want to get its current transform translation. That is how much it is shifted to the left, the right, the up, or the down. And we're going to be adding our mouse cursor delta to that. Of course, we only do that if our dragging Boolean variable is true. So we just drag that in, convert that to a branch. And if that is true, what we do is we get our mouse event, we get the cursor delta. That just tells us how much our mouse has moved between the last time this was called and this time. And we add that to our current transformation. If we add those two things together, and then we just get our canvas and we set the render translation specifically, that's pretty much everything there is to that bit of it. Again, this needs to then also return the fact that it was handled, so that the widget system knows that the mouse movement doesn't need to do anything else. And as simply as that, we can now open this up and we can see with the right mouse button, we can already drag this around. If I use the middle mouse button, we can also drag it around. The mouse button leaves, it stops dragging around, and that means that our panning just immediately already works. That's the easy bit. It's actually surprisingly, stupidly easy to pan around an image in Unreal. The next tricky bit is going to be the mouse wheel, because we want to be able to zoom in and out. And for that, we're going to need to set up a couple of quick extra variables that we want to be able to work with inside of this function as well. So variables right here. We want to have a minimum zoom level that we can be at. Of course, that's going to be a float. This might actually make sense to expose as being instance editable. So if you have panning widgets in multiple places throughout your game, you can set different minimum zooms and maximum zooms, which is the next thing that we're going to be adding. To each individual instance, because some of them you might not want to be able to zoom in as much as others. Then we want to get our current zoom level. That one doesn't need to be exposed because that's just for your code to look at. And then we have the zoom step, which is how much we zoom in per tier of your mouse wheel movement. Again, this, to be fair, I'm saying mouse wheel movement. We're doing with the mouse wheel at the moment. Of course, you could also map this to any other button inputs, and then a zoom step would just be one press of that button. But we're going to be doing things with the mouse because I always like to also make it zoom in on wherever your mouse cursor is, just like this blueprint graph would do, right? Everything here is going to be focused on the mouse, but it's pretty straightforward to change this over to some other method of zooming in and out. So first and foremost, we need to figure out the origin point of our zoom. So where is our mouse cursor? So we get our mouse event, and there we get the screen space position of the mouse. Coming off of the geometry of this, we want to do a absolute to local coordinates, because this gives us screen space coordinates. What we want is we want local coordinates. We want to know where is the mouse relative inside of this widget specifically, not on the screen. We want to know where it is within this widget. That's how we get that. We can promote that real quick to a local variable. Doesn't need to be a normal variable, just local is fine. It's actually even better. And we'll call that something like origin point. It's also nice to set this up as a variable, because if you ever want to do anything with a different origin point for your zooming in and out, all you need to do is change whatever this code is doing to set your origin point. So having that as a variable just makes it easier to change your code at a later date if you wanted to. Then we need to remember what the current translation of our canvas is. So once again, we got our canvas panel. We get the transform for it, and then we split that structure bin, and we promote that to another local variable. Call that something like alt trans for alt translation. Then we get our current zoom, which you might actually want to set up a default value for your zoom as well. It's likely going to be just 1. And our minimum zoom and maximum zoom, also set that to defaults, like 0.2. So it'll be maximum zoomed out to about 20% of the size, and then 3, so that the maximum zoom in is about 300% of the size. And our zoom step as well, let's make sure that's set to something like 0.1. If that's a value of 0, everything kind of freaks out. But we get our current zoom and we promote that to a local variable as well, because we're going to need to remember what we were zoomed at and then what our new zoom will be to offset our translation here in a moment. So before we start changing any of these values, we just kind of need to set them aside as local variables that we can then look back at like, oh yeah, it used to be this. We'll call that something like all zoom. Then we'll actually set the zoom itself to a new value. So this is the global variable, the variable for the whole widget, the zoom thing that we just made. And the way that we're going to be setting that is we're going to get our zoom and we're going to be adding to that our zoom step multiplied by our mouse wheel delta. So we can get the mouse events again, and we can get our wheel delta. And this will effectively always be, if you have a mouse with like steps, a +1 or -1 value. If you have a mouse without steps, my mouse can go back and forth between the two, might be able to be a different value, but it still is a value that either says positive direction or negative direction. That's mostly what we're doing this multiplication for, is figuring out, do we want to zoom in or do we want to zoom out? So that multiplied value is what we're going to be adding to our zoom, and then we want to be able to clamp that between our minimum and maximum. So if we are trying to zoom out beyond what we should be allowed to, it'll clamp it to the minimum, same with the maximum on the other side. So we can clamp float with this node over here, and then we just put in our minimum zoom and our maximum zoom, and that's going to be setting our new actual zoom value. In this way, we have our old zoom just tucked away for use in a moment, then set our new zoom so we have both values ready for use. And we're actually going to immediately use both values as well, because we're going to be making one more local variable here, and that will be our zoom ratio. What is going to be the ratio between our old zoom and our new zoom? This is a value that we're going to be using to offset our translation in a moment, because when we zoom in, we're technically always initially zooming in from the origin point of our canvas. So then after we've changed that scale, we need to then adjust the translation of our canvas to account for how far away we were to begin with. Again, if this doesn't quite make sense yet, hopefully once we actually start getting into the math for the translation and using the origin point for that, it might make a little bit more sense. But the way we get the zoom ratio is getting our current zoom, after we've just set it here, and dividing that by whatever the old zoom was before. Quickly cutting in here during the editing, I am an idiot. I am setting the zoom ratio here by dividing the zoom by the zoom step. Obviously, that's a bad idea. You want to divide the zoom by the old zoom, as I was saying out loud. But if you're looking at this at any point and you're like, hey, dividing it by the zoom step, I'm only finding this out after the fact, I just pulled in the wrong node. You want to do zoom divided by old zoom. So if we're here at either the minimum or the maximum, or somehow the zoom step ended up being 0 here, these values will still be the exact same, and dividing them will be a value of 1. But if these values are not the same, they are going to either be a value under 1 or over 1, and that's going to help us offset everything in the right direction. So now let's build the new translation, or the new position for our panning widgets. Just to keep things organized, I'm going to make that a new local variable as well. And we'll call that something like new position. And that's going to be a vector 2D. So here, vector 2D. It's going to be an X and Y coordinates, and we'll drag in a setting node for that as well. If you're not familiar, by the way, you can drag in, hold and control, and automatically get a getting node. And with Alt, it's automatically going to be a setting node. One of those things that I every so often just like to throw in, making sure everybody is aware. So we'll get the origin, and from the origin point, we're going to be subtracting some values. And the value that we'll subtract will be the origin point minus the old translation that we have tucked away. And then we will multiply that with the zoom ratio. So what this does is it checks, hey, how far away is our origin point from our current translation? So let's say we have a square. I just opened up a painting program real quick because my on-screen painting isn't working. And this is our 0 point, right? We have everything aligned to 50%. Our translation says we are about like 100 translated away. So our translation point is over here, and our cursor is, let's say, over here. What those two nodes are doing that we just placed is getting the difference between these 2 points. That's what we're doing. And then we're multiplying that by the ratio between our old zoom and our new zoom, so that we know what the delta, the difference between these two, will be with our new zoom as well. So then when we know that difference, we can subtract that from our origin point, and that will be the new translation. So now that we have those values, it's just a matter of getting our canvas panel again. So we have a canvas panel reference already here. So let's just copy paste that. And we can just set the render scale and set the render translation. And make sure that you use translation and not transform. And then we simply just get our zoom and our new position, and those are going to be set to our scale, our render translation. And then of course our return node here needs to make sure that we tell it that it is handled. Now in your panning widget itself, you might want to go into the render transform and set the pivot to being 0, 0 instead of 0.5, 0.5. Because what you'll find is everything actually kind of works fairly well now. If I try to zoom in, and I zoom in with my cursor right around the center, it actually zooms in and out based on a point right here. If I zoom in and out with my cursor in the top left, it zooms out around the center. So everything is just offset by about 50% of the size of the widget. And that is because the widget itself here is actually pivoting from its center. So it kind of has a built-in offset. You can update your code to get your origin point and then subtract the half the size of the widget. What you can do instead, which is just much more straightforward, is setting your pivot to 0, 0. So it actually pivots from here, which means that everything will be lined up now. So if we just zoom in and out now, you can see it actually zooms in and out based on my cursor's position. And if I put this on the face, you can see zooming in and out, the face itself here relatively stays under my cursor. So we've got this panning, we've got zooming in and out. So if you want the project files for everything, start to finish, for the entire skill tree system, even if you've just watched this for the panning and zooming widgets, there's links down below in the description for YouTube members and patrons to get the full project files for everything, of course, including this panning and zooming. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. My Cave Students tier supporters, Oiku, Earl, Monseville Urno, and my Cave Digger tier supporters, Mauricio Farias.